Hello, and welcome to my talk. Thanks for coming to this late slot. I know some of you already had a long day, but now you're nearing the highlight of the conference, which is, of course, not my talk, but the party afterwards. But I'm trying to make it quick, and hopefully you won't feel the time passing, so you're basically already at the party now. I'm going to talk about events, well, not party events, but events in software architecture, events in software. And about misunderstandings and confusion. So to minimize misunderstandings and confusion, here the first three slides are about context and why I talk about this. Because everybody talks about events, right? I think these are even 4 years old or so, but it used to be a kind of advanced, exotic topic, event-driven architecture and event sourcing, but now with microservices, Kafka, Lambdas and so on, everybody, well, a lot of people are exposed to events. Or actually, I could ask you, so who has worked in some form or the other with Kafka, event-driven architecture, events, event streaming, something? Cool, almost everyone. Okay, so you will actually know this if I talk total shit. Cool. So talking about shit, yeah. Communication is difficult, right? So we think we communicate, but we never know what the other person understands. I might talk about events and event sourcing, and you walk out, and what you have in your head is absolutely not what I thought I was talking about. And this is actually the topic of my talk. This is basically the whole point of my talk. As event-driven architecture and event streaming and so on becomes more popular and more widespread, it also becomes a bit diluted. Like people, the sort of definitions get blurry and people are sort of exposed to a certain flavor of it, or maybe they work in a company where they tell them, oh, this is how it's done, but actually only this company does it like this, but they don't have the community exposure to learn that other people are actually talking about other things. Or they do it in some weird way that doesn't actually leverage the advantages and so on. So we're going to talk about what we mean by events, event-driven event sourcing, and so on. So it's a lot about definitions, I think, and what follows from these definitions. So this is what the talk is about. If you're not interested in this, you can still leave. And also, I know your fantasy is unlimited, and you will sort of maybe what I talk about triggers some weird fantasies in your head, what you think I'm talking about. So I'm talking about simple stuff, right? Don't try to think up sort of super exotic scenarios with I don't know, weird behaviors. We're talking about events, or we're talking about collaboration between services, right? Like a typical, say, microservices architecture. You have a goal that you want to achieve, like, for example, selling some goods and shipping them. And instead of building a monolith, you build a couple of services that work towards this common goal. So these services have to communicate. And this is the kind of communication and collaboration I talk about, right? These are the events. This is kind of the world we're in when we talk about events here. So very businessy, so business transactions that happen between multiple services. The reason why I give this talk is also, well, it was kind of triggered by real-world experiences, right? By stories where I saw, okay, this is weird, this shouldn't happen, there's some misunderstanding here. So the first story, I'm going to start with the first story. So I was, let's say I was consulting a company that was actually not about an order service, but the domain doesn't matter. We had a scenario where something happened in some service, and we wanted to convey this information that something happened to some other service. So we said, okay, this is a great case for event-driven communication. The order service, I don't know, creates some order created or order accepted events, and this goes to the shipment service, and it will know what to do with that. All good, I go away, I come back later. This is what they built. So what did I think about this? My reaction was the following. Because, I mean, so maybe you think, oh, well, that's not that bad. They put some thought in it and bought some stuff, built some stuff around it. Why is this so bad? Well, of course, well, what do we see? Maybe we talk quickly about what we see. The simple picture was we had a service, some events, and another service. Now they thought, okay, but what if something goes wrong? I sent this event to the other service, and the other service, there's some mistake. I need to know that the receiver actually could process this and then successfully work on this. So I want some feedback about this. I want to see what they did. And so I introduce something else that kind of supervises this. And if it goes wrong, maybe I can retry, or can introduce some retry policies, all great stuff. But that's not what events are about. What is an event? So first definition here. An event is a fact. What did I write here? It's a fact. It's something that happened. And the thing with things that happened is they have already happened. They will never be undone because time only goes forward. So if I put something here, I don't know, I put this bottle into this bottle holder, bottle placed event. There's no way, this is never going to be undone because I can't turn back time. I can take the bottle and put it somewhere else, but that's a new event, right? So another bottle placed event. Now the bottle is somewhere else. Of course, this can happen. But at this point, when I place the bottle here, and I said the bottle is there, there's no point in the chair saying, oh, I can't process this. This is like, oh no, this is an error. It has already happened. So that's the problem I have with this. This whole shebang that we build around this, the whole reason why we use events is that we don't have to build this. If we use commands, we're going to come to back this later, or let's say if we just use some sort of other communication, some generic messages or calls or whatever, maybe we want to do this, we want this feedback or so on. But the whole point of events is, an event is a fact. If somebody gets an event and they can't process the event, that's their problem. It has already happened, right? So in this case, in the order service, a meaningful event would be, I have accepted the order. The customer submitted something. I said, this order has been placed. I don't say anything about the item being available or something being paid or whatever. But this thing, from my point of view, if I'm the customer, I submitted the order, I get an email, okay, we got your order, we'll take care of it. So for me, this is done. This has happened. Send an event. It's now it's other people's problems. You've gotten terribly quiet here. I hope I don't shock you with this. So I mean it though. So this is what we just saw. Well, there was Kafka in it, right? We used Kafka to send stuff from one service to the other, so it has to be event-driven. No, just using Kafka doesn't make things event-driven. Also, it makes the communication asynchronous, non-blocking, whatever. All good. But still, that's not an event. Just by being asynchronous, I'm not event-driven. Something is event-driven because we work with events. And something is an event semantically, if it has event semantics, if it expresses something that has happened. Yeah, I already said this, right? There's no going back. So I tend to, sometimes I get sort of excited and I talk about stuff that comes on a few slides later. So sometimes you will see slides I've already talked about. So what I already said, there's no going back. If I issue an event, like in the upper part of the slide, I send an event order placed, then it's the shipment services problem. Of course, this is not the whole system, right? We can still deal with errors and things can be alerted and everything can happen, but the caller is out of the picture, right? Because it's not a caller anymore, it's the emitter of an event. And if we don't do it, if we don't leverage this, if we build it like in the upper half, then what's the point? Then why would I even think about, why would I even design my system around events if I don't leverage the advantages that I have, the clear responsibility separation, right? That I can say for the order service, it's absolutely clear where my responsibility ends. When the order event is submitted, I'm done. This is what we want. This is what we get from it. If we don't get this and build something around it, that we don't leverage this, then we might as well do something else. Okay. Oh, well. I said we are in a certain context, right? This kind of business services. And I thought this is worth mentioning because of misunderstandings. I once did a workshop where we talked about events in the system, and we brainstormed what events would happen, and people came up with, oh yeah, the user clicked a mouse, there's a mouse-clicked event, whatever. These are not the events. Well, I say not all events are interesting. I guess they are also interesting. Just not the events I talk about now, right? So if you think about logging, some people talk about events there, or maybe you have some probes, some data, IoT data or so, a stream of events, or a user clicks or so. This is not what we talk about today. Also interesting, but not really about event-driven architecture, right? We talk about business architecture. Just saying, so we're clear. Let's introduce another term then, because event is too generic. What we really want to talk about, or what I want to talk about with you, is domain events. Right? Let's call them domain events. They're things that happen in our business domain. And, well, we decide to emit the event, so we decide to inform other components in the system about something. So we could say they're interesting. If we think they're interesting, right? Something interesting happened in my domain, so I emit a domain event. An order was placed. I think, oh, this might be interesting to other people or to other services because something has to be done. Let's emit an event. So that's a domain event. These are the events we talk about. Well, actually, now I have talked about this. Let's talk about something else. Where do domain events usually come from? This is important later when we talk about source of truth, and so where's the actual source of the data? Where's my book of record? So domain events usually come from a domain service, right? I build a service, in this case the order service, and the service gets commands like please place an order. Maybe it also consumes some events from other services. This will lead to some state change in the order service to some order. So some order is created or the state of an order changes and we emit the events. Right? So important here, it's inside the order service. We're going to get back to that later, right? But they come from inside of the service. What do we achieve by communicating by events? So we have this event stream. So we can decouple the services at runtime, right? I can remove a runtime dependency. If I call the order service, no, if I call the payment service and I say I want to pay for order 1, 2, 3, 4, and now the payment service has to ask the order service, what is order 1, 2, 3, 4, please? Then there's this runtime dependency. If the order service is down, then I can't answer this query because, or I cannot execute this command because I don't get the order information. So I'm smart. I say, okay, I'm going to push the order information. I'm going to publish the order information on a topic so the payment service can subscribe, and they can build their own little model there. They take the information out of the order that they need, and whenever somebody wants to get information about payment 1, 2, 3, 4, then I can say, oh, it's actually for this order. I don't even have to ask the order service anymore. So very basic event-driven stuff. Now, is this event sourcing? You can tell by the question mark I put behind this. I don't think so. Or, well, I think technically, if you go by the definition of event sourcing, you could say it's event sourcing. Well, maybe what event sourcing, we're going to come to this, but you probably already have a vague idea about it, right? The idea is you have a stream of events. I'm going to go quickly back. And you say, okay, in this case, you would say, okay, the source, or well, the stream of events, this defines my truth for the orders, right? I could throw away these orders oh, I also have this pointer thing here. I can throw away these orders anytime if I just have infinite retention here. Infinite retention means I just keep the events. So I put the events on my, say, Kafka topic. I just leave them there forever. Now, I could, at any time, I could just rebuild all the orders from the stream of events. So I could say, okay, these orders, they're actually event-sourced. Like, okay, well, the source of these is the events. I sort of go through the events. This gives me the state of the orders. So that's why I say it's not completely untrue. You could say this is event-sourced. But when people talk about event sourcing, especially the people who invented, or will invent a lot of, especially the people who in the past worked a lot with event sourcing and built Event Store DB and invented CQRS and stuff like this, they talk about something else really, or like a different flavor of it. So event sourcing is something. There's this great article by Pat Helland, data on the inside and data on the outside. We have data inside our services, we have data on the outside. Maybe different consistency guarantees and so on, different encapsulation definitely. So when we talk about event sourcing, this is really a persistence model and it happens on the inside of a service. We looked at orders, right? We said, okay, this is the source of truth for the events we talk about there. So I get commands in the service like pay for something, I get events from somewhere else. I handle these commands. I handle these commands, And this might lead to an event journal, right? So I don't store the current state of this payment. I store the event, like payment, I don't know, has been paid for, whatever the event is. And then I can always just sort of fold over the events. Why not go through these events, maybe for just one entity, and I end up in the payment state, right? So this is event sourcing. I don't manipulate the state directly. I don't save the current state as I would in a CRUD application, right? With sort of update, whatever. No, I just process the command. This will result in an event, like payment has been made. And so if I pass the events, if I go through the events, the payment state that I can derive from this will be, OK, it has been made. Now, if you want to make, sometimes you want to talk about all the payments. You want to see maybe what was the average or whatever, or you want to have some other kind of query where you don't want to go through the events. And you do this by projections. And this is what CQS is for, right? So we separate commands from the read side. Command query responsibility segregation. Now, if we want to query all payments, or we want to have a query like, give me all payments that were bigger than €100, then we have this read model where we can do queries like this. Well, this read model can be anything. It could be a SQL database, could be Elasticsearch, could be whatever. Where it can be some pipeline for analyzing. So this is where we do the queries, and this is event sourcing. And of course, we project the events into a read model, right? And we can have multiple projections. If we say, oh, this is an event that leads to an interesting state change, like this payment is now completed, then we can emit an event to the outside, right? It's just another projection. You could say this is basically just a remote read model, right? Some other read model can be filled with this somewhere else. And that's an event stream. And this is what, so that's kind of an important separation. Is it on the next slide? Oh, so, OK, let's talk about event sourcing first. Event sourcing is storing of the current state by storing a sequence of events. We just saw it on the slide, right? Should be pretty straightforward. I just create a log of all the changes, and of course, by going through all the changes, I come back to the state that's relevant then. Event sourcing happens inside a service, right? It's inside your microservice or whatever. Event sourcing has existed a long time before Kafka became popular, right? You don't need Kafka to do event sourcing. Most event sourcing systems use a plain old database like MySQL or Mongo or well, Postgres. You can, with Kafka and K-queries and so on, you could also theoretically use Kafka for your event journal. I would not recommend it because it makes querying unnecessarily hard. Event sourcing is in the space of persisting data, right? You have CRUD or relational databases. You have all sorts of NoSQL databases that you want to work with. Maybe you want to store your data as a graph or something. And in this area, one way of storing your data is as a sequence of events in an event journal. So this is event sourcing. Has nothing to do with communication between services. Event streaming is what we call, well, basically streaming events from one service to the other, right? So if one service publishes a lot of events on Kafka, other services subscribe to them, that's event streaming. Event streaming, okay, subscribing to events from other services is the basis for collaboration between services. You could say that's event collaboration then. And that's what they usually use Kafka for, or nowadays maybe NATS or Pulsar or Kinesis in the cloud or Azure Event Hubs, what have you, Google Pubs Hub. Interesting, yeah, a very interesting and important point. That's an API, right? If you define the APIs of your service, you have REST APIs, or maybe you have REST APIs, you have synchronous APIs, maybe you have gRPC APIs, whatever, and you have event publishing. That's part of the API. Event sourcing is not, right? Event sourcing is internal. So don't let people tell you you have to publish things on Kafka and then that's event sourcing, because that's what some people will do. It's not. Event sourcing inside of a service, persistence. Event streaming is an API, publishing events to the outside. Oh, now, maybe you've been confronted with this, or maybe you will at some point. Now, of course, you could say, theoretically? Well, we looked at the service, and it would get some commands and do something and put it in its event journal, and we had the projection, right? We would derive the state from the event journal and come up with our internal state. Now you could say, if I have this external event stream anyway, why don't I just use that as the event log? Right? I could, instead of putting it into my sort of internal journal, I could put it on an external event log, message bus, whatever, and listen to that. Basically, what people like to call it. Some people call it data inside out, or listening to your own events. Again, there's a question mark here, so you can see I don't think that's a good idea. Why is that a bad idea? Because you give up everything. Well, even in the event-driven world and with new architectures and microservices, some fundamental principles still apply. We want encapsulation, right? We want microservices to be the masters of their domain and the data model. We want to be able to change the model without others being affected, because we separate this. We have our internal model that we work with, and then we have the APIs to the outside. Why give this up? Nobody would take a relational database and say, oh, this is my API now, this is my data model. Other services can just go through these tables and get the data. I know people did this, or maybe people still do, but people have done this in the past, but it didn't really work out well, because then you have this global model, and if you want to change this, everybody is affected, and there's a lot of trouble around this. So why repeat this trouble with Kafka and say, oh, I'm just going to define a schema for this type of event globally, and I'm just going to publish these, and then everybody just sort of takes these events and builds their model from that? So this is, some people propagate this, maybe because they want to sell certain products, or maybe because they're in love with this architecture. But I think that's a very specific, or you must have a very specific use case for this. And also, interestingly, you can do this, well, basically now, or maybe after the talk, which I would appreciate. Go on the internet and look for people, look for blog posts that say how we failed with event sourcing, or why event sourcing doesn't work, or don't believe the internet, event sourcing is hard. Then you read these articles, and the kind of event sourcing they describe is this. No, it's the one before. It's this, right? The projects that you read about in the internet that say we failed with event sourcing because it was so, it all got sort of entangled and we couldn't change the events anymore at all, these are the ones that rely on this kind of architecture. Because, yeah, this is actually one of the aspects, that here the source of truth is still within the service. And this has a nice isolation aspect, but also it gives you some freedom, right? Let's say something went really wrong and you need to fix something. I don't know. Of course, if you store events in your service, events are meant to be unchanged and forever and so on, right? But you can do, you could do some transformation, and you can say, okay, I have a new event version, and now I want to transform the old ones into a new version. You can do some transformations, so you can do things like, well, you can do dirty things like what people call, basically throw away some events and things like this. You cannot do this in this kind of architecture, right? You cannot, if you have this Kafka topic with infinite retention, and this is the source of truth for basically all of your company, you will have a hard time going back and say, oh, I want to convert these events, I want to throw some away or so. This is sort of a really, really strong commitment on the schema you have and on the data you persist there. While this is kind of more the world, the world that deals with unknowns, right? We have our sort of internal thing where we can be agile and we can adapt. We have APIs where it's maybe a bit harder, but they are constrained, they are public. So we are a bit more stable there maybe. But this gives us a lot of flexibility. And it's not that much more complex, I'd say. Actually less. On the diagram, it looks like it has a bit more boxes, but it also gives you the possibility to have strong consistency on your command handler side, which was also difficult in this other model, right? So also architecturally, it has a lot of complications relying completely on an external event log. Just don't do that. And also, never believe you have to do this, or that's the only way of doing event sourcing. You can do definitely event sourcing without event streaming. You don't have to listen to your own events, and you can do it without Kafka, right? Because, as we already learned, event streaming on the outside, API, between services, event sourcing on the inside, persistence within one service. You don't have to listen to your own events. It's just a very special case. And there was event sourcing well before Kafka. And, okay, talking about doing event sourcing without event streaming, what's probably even more relevant is you can also do event streaming without event sourcing, right? So we can talk about event streaming and stream events between services, and also build local read models of the data from other services in our service and so on, all without any event sourcing internally. Each of these services, they can persist their data whatever way they please. They can use relational databases, they can use files for what I know, or you can use some key value store. They just, if there's an interesting state change, they just need to produce an event. But again, outside API, how they do it internally, if they use event sourcing internally, absolutely irrelevant in this case. Okay, that was the sort of that was the groundwork. Basically, that was the most important part I wanted to get across, right? So have a clear distinction, have a good understanding of what events are. It's about semantics, right? Events are facts. If somebody says, oh, I need to know, I emit an event, but I need to know what the receiver does with it. I need to get some feedback if it was processed correctly or so on. Then there's already something wrong. You shouldn't even know who the receivers of your events are. Maybe there are 10s or 20s, and you don't want to check with everyone. If somebody can't process an event, it's their problem, right? And this is how you can architect your system around this. Event sourcing on the inside, persistence, event streaming on the outside. Don't let people tell you Kafka is event sourcing or you need Kafka for event sourcing. Totally different things. Okay, now if you go in the internet, on the internet, whatever, look for events and you'll find an article by Martin Fowler. So I just thought, while we're talking about events, why not mention this briefly? And of course, I'm not going to argue with Martin Fowler. I think that would be, that's not something, not a battle I would pick. Also, I think he's a great guy and writes a lot of great stuff. He has this classification of events. So when we talk about event streaming, event sourcing, and so on, a natural step is to think about different types of events. And he says, okay, when you talk about his talk is called different types of event-driven architecture, because event-driven architecture, of course, can mean both. Event-sourced services, for example, or event collaboration between services. For me, it's always about macro architecture, right? The communication between services. When I talk about event-driven architecture, I'm interested in how the services communicate, not so much how they store the stuff within, which is micro-architecture concern. Each team could do this differently if they like. So he says there are 3 types of events: event sourcing, event notification events, event carried state transfer. We talked about event sourcing events, right? These are events, local events for event sourcing, completely unrelated to streaming, for persistence data on the inside. So that's a little grudge I have with Fowler's article. I think he should make the separation clearer between the event sourcing events and the rest. Then he talks about notification events, and actually this is also a kind of architecture or a kind of pattern some people like to use. We say, okay, my event just tells me that something happened. It doesn't actually carry the data. So I would get an event that says order created 1, 2, 3, 4. And that's all the data there is. So I have to go back to the order service and say, oh, please give me the data for order 1, 2, 3, 4, because I want to know what's in it. Right? So I only get the notification, have to go back to the other service to check what the actual data is. I think that has a lot of disadvantages. I wouldn't usually use it. Right? So first of all, you have to call back to the other service. So we talked about temporal decoupling or one-time decoupling. Right? I said the point of subscribing to the events and building my own model is also that at one time I don't have to query the other service, right? I can run independently of that other service. Now this gets lost if I only get the notification. Now I have to ask the other service, give me the data. So I have this one-time coupling. Also, if I have an event that carries state, right? I have this nice history of the state changes. Imagine 2 changes happening rapidly after each other. So I have a change, again, I have an order that was created and immediately cancelled. So now I get the notification that the order has been changed, or I get the notification the order has been created. I query the order service and say, give me the order, but this order has already been cancelled. So I get the latest state, but not the state that actually relates to the notification. Not something I really want. So I would only use notifications with immutable pointers, if you will. So if they point to a certain version of a certain object, or, well, a good example where to use it is maybe generated files. If you generate a PDF or so and you want to notify some other service that this has been generated, this is a kind of payload you probably don't want to put into, say, a Kafka record, right? You want to keep events small and don't want to put like hundreds of megabytes of PDF files in it. And also the file you generated is probably immutable, right? So if you generate the PDF, put it on an S3 bucket, and it has some UUID that will never change, and the file will never change. So this pointer to the file that you communicate, this link, is actually fine, right? It actually is persistent. It will always be valid as long as the file is there. So for these cases, it's fine to use notification events. But all the other stuff we talk about, like, oh, here's this order, here's this payment, and so on, all the collaboration between the services, that's really event-carried state transfer. Usually you want to at least include the interesting changes into your event. Some people put the whole entity into the event, has some advantages, has some disadvantages. Different topic maybe, that some people call those fat events, right? You could imagine this, I don't know, there's a customer change, a change of address or so, but instead of just changing the changed street address, you just send the whole customer object. Yeah, that would be a fat event. But this is a whole, we could do like a whole different talk about designing events, what are good events, what should an event express and what shouldn't it express. Just so you know, if you look at Fowler's stuff, how it relates to the things I talk about. Oh, also, of course, if we look at events, maybe it's worth looking at things that are not events. This is like class. What are not events? So especially in domain-driven designs, all the communication is usually separated in sort of three categories. You have events, and you have commands and queries. Right? So, little story. If you go to Confluent, the company behind Kafka, and look at some patterns, I think there's some page that says there are command events. That drives me nuts, and not only me. There's a whole YouTube video about that there are no command events, the popular one, because a command is not an event, right? You know it by heart now, right? An event is a fact. An event is something that has happened. A command is telling somebody to do something or telling some service to do something. It expresses an intent. I say, I want to place an order. I want to delete this. I want to do whatever. And it can fail. Right? So for a command, I want this feedback. For a command, I always want to know, has it been executed or has there been an error? When the command has been executed successfully, then maybe an event is generated. Right? So a lot of end-user interaction, if you will, is with command and queries, right? I submit a form, that's a command, right? That's I want to place the order. I want to browse the catalog, these are queries. But inside, within our system, when we process the command, then we can generate events from this and work with the events. So commands express an intention, can fail. A response would be, well, I don't know, 200 OK or whatever, or well, OK, I don't want to go into status codes, but it would be a yes or no, it worked or didn't. Queries, of course, give you information back, right? I say, give me all products that are red, and I get these products. So this is a good way of thinking about communication between services, right? What are we talking about? Is it a command? Is it a query? Is it an event? But keep in mind, is that the next slide? No. Oh, this leads to different patterns and different architectures. If I work with commands and queries, so this is like, okay, this is just an arrow, I know. Imagine this is a workflow, right? So you have a workflow, like an order workflow, where a couple of things have to happen. For example, you want to reserve the inventory and you want to see if the payment is there or so. And the interesting bit here is, okay, on the top there's the workflow. With a command, it always goes back, right? So my workflow, my process doesn't stop. My process maybe has a pause. I issue this command, but then it comes back to me, and I continue my process. I continue my workflow. Maybe I query something, and I get it back. With events, we also need to break down our workflows. Right? If you think about your system as you would in a monolith, or if you think about your order flow as just one process where the order is placed, the payment is made, the inventory is reserved, or so on, then you will end up with the one we saw previously, right? You have this one process and all the interactions always go back to this one process. This will lead to a certain architecture. This will lend towards orchestration. This will lend to centralization. You also have to break down your workflow into what some people call micro workflows. And this is, I think it's a super interesting topic. If I'm allowed to come back next year, I'm going to do a talk just about this slide and the one before. Breaking down workflows into micro workflows. So the idea there is, I don't have an order workflow. I have a workflow of order acceptance, say, and this ends when I get the order accepted. I emit an event. Then this process is absolutely completed. I emit the event, and then, I don't know, some inventory service gets this event, and the workflow there is to check the inventory. And then it will emit an event, and then the job is done. This leads to a very nice separation of responsibilities as well, right? As I said in the very beginning when we talked about this, the very simple service and then the things they build around it. If you stay on the simple side, the team responsibilities, well, if we say, okay, there's a team associated with this service, right? There are people who have to build this and have to maintain this. Your responsibility is super clear. When the event is emitted, you are done. With the centralized workflows and orchestrations and so on, there's always this area of mixed responsibility. Like somehow something fails in your service, so kind of the team for the service is responsible, but now the orchestration or the workflow or the other service that kind of orchestrates or that manages the process has to deal with this and has to deal with this failure. So they will always be involved as well. I like this clear separation of saying, okay, I emitted the event, I'm done. Of course, you still need the visibility and so on, right? So instead of reporting back to the order service, you will have something else. Maybe you have some order state service or so that just consumes all the events and maintains an order state object just for visibility, just for you to monitor it and to see it. But that would be totally outside of the workflow, right? It would not have any orchestration or process management responsibilities. Yeah, I could talk for this. I could talk about this for days. So that's what I'm talking about. When we stay on the simple side, if we build micro workflows, then we're actually leveraging this event characteristics. But then we're actually making use of events, and it's actually worth using events and being event-driven because we can build simpler systems. If we don't do this, then, okay, it doesn't look super complicated, but it really explodes at some point, right? If you have all the central orchestration and shared responsibilities, then this will lead to much more complexity. I think it's a mind thing, right? It's really about shifting your perspective and looking at things differently. It's not so it's not technically difficult. It's difficult because we're so used to defining these workflows from end to end and sort of associating this with control and visibility and so on. But if we let go and sort of accept that people, or in this case services, make a certain promise to do something, then we can build promise-based systems, which I think is a very powerful pattern. So we're coming to the end, and we should. So watch out when people talk about event sourcing. What are they actually talking about? Are they really talking about event sourcing within a service, persistence, or are they talking about this data inside out, listen to your own events, and so on, right? So because this can lead to a lot of confusion. And don't let, these are both valid approaches, but just don't let people tell you that data inside out or listen to your own events or putting everything on Kafka is the only way to do event sourcing. As I said, it's definitely not. Yeah, I think the data inside out pattern has a lot of disadvantages, especially in terms of encapsulation and clear distinction between my own internal persistence model and APIs. I think we should clearly separate this. So this is my advice to you. And I talked about these workflows and that we have events and commands and queries. And I also talked about this perspective shift, right? I think what we need to do is challenge these workflows. When we get started, when we talk to the business, or if we look at a monolithic application and want to convert this into the microservices world, we will often this will often lead to a very command-based orchestrated flow, right? Because that's how it used to work in the monolith, or that's how people think when they think about the whole process. But this is not like God-given, right? It's not when you look at two services and you see, okay, this communication is clearly command-based. Maybe it doesn't have to be, right? You can change the perspective. You can say instead of calling a service and telling the service initiate this payment or deduce this money, you can also emit an event and say, okay, this order has been placed, and the other service will see this event and will react on this. So these are design decisions. You have to keep this in mind if you look at systems. This is not something that is, there's no natural law that says, oh, these have to be commands. You can probably switch the perspective and design it in a different, more event-driven way. And then the foundation of this, of course, is the event collaboration between services. Yay, that's it. Time for questions.